So last day we looked at this topic, topic 16, solving rational expressions. A little, I don't want to say complicated, but like a lot of writing we did here. So make sure you check out that class if you haven't seen it. All classes have been uploaded onto YouTube. So you guys can check that out at any time that you want. Maybe if you have some time after today's class, you might want to check out the last two videos especially. And I mentioned so that would be topic 15 and topic 16. I mentioned in the other class on Thursday that you might want to review factoring. We're going to have our second test on June 8th. I almost said 18th, June 8th. That's Tuesday, June 8th. And in order to do well in that test, you will need to know how to factor, because everything we're doing today kind of everything we're doing last class, today's class, and in the future class revolves around the idea of factoring. So let's keep moving with topic 17. And let me just make sure I'm sharing my screen here. Yep. We're going to one second. We're going to apply this concept now of rational equations to word problems. Yes, someone has a question?
Until which topic the test two?
I don't know yet. Well, I'll let you know before test 2. Okay.
Okay, thank you.
No problem. The reason I can't answer that is because we need to see where you guys and where the other classes, as you know, there's many classes. We need to see how far everybody gets. So I can't answer that. Like, I don't want to say topic 22 if it's not going to be that. So I'll let you know closer we get to that test. Okay. So as usual, the date is for sure, though. The date cannot change. So it is Tuesday, June 8th. So anyways, as you guys know, we were solving these rational equations, and we're going to try to apply that now to word problems. So we'll do, this is a pretty short section, topic 12. So we'll look at a few of these and then get into topic 18. This topic, I think, is only 2 examples, and then maybe I'll do one with you. And then I'll get you guys to practice, and then we'll move into the next topic. So here it says, let me zoom out. Actually, no, I'll leave it like this. An athlete's average biking speed, or speed biking, I think it should be biking speed, is 14 kilometers an hour faster than her average running speed. She can bike 31.5 kilometers in the same time that it takes her to run 10.5 kilometers. What is her running speed? It sounds really weird to say what is her speed running, but what is her running speed and what is her biking speed? So how fast can she go? So what we're going to do is we're going to set up an X and to solve for. So we're solving a rational expression for one variable. This is a little bit different than, say, when we were doing rational expressions about like the price of tea and the price of coffee. If you remember, like doing that in, I can't remember the topic, maybe topic 11 or something. Or like the concentration of one solution versus the concentration of the other. We're going to kind of solve for one variable here, and that's going to be X. Now, we know that the speed biking is given related to the speed of running. Let me just get my pen here. Hold on one second. Okay, good. So it says that this athlete's speed biking is 14 kilometers faster than the average speed running. So we did this, oh man, back in topic, right when we started algebra. So I can't remember the topic number, but right when algebra started, we looked at turning this into algebraic expressions. So 14 kilometers faster would be plus 14. Right? If I said you are driving 14 kilometers faster than me, and I was going 100, you would be going 114. So what we're going to do is we're going to set the speed running equal to x, and the speed biking will be x plus 14. Okay, so again, kind of like what we did in that topic with the word problems. I think it was like topic 11 or 12. I can't remember the numbers. It might have been topic 9, actually. Yeah, I think it was actually topic 9. We're going to set up a chart here. So we're going to have running, and we're going to have biking, and we're going to fill out the information that we know about these things. So the distance that this person travels while running, it says that it's 10.5 kilometers. The distance that this person can bike is 31.5 kilometers. Okay. The rate is, this is kind of like a physics question. Or, I mean, it is a math question, but you might hear about this in physics. The rate is the distance over their time. It's x. In this case, it's x for running. And the biking rate is x plus 14. So the time that it takes them to do this is also written in, or we can also calculate time is going to be, and well, I guess I don't need to write it down. It's right here, is the distance they travel divided by the speed that they're going at. So it says, our distance is going to be the rate times the time. Well, that means time, we rearrange this equation, is going to be the distance that they travel divided by their rate. So we're basically setting up an equivalent situation here, two equivalent ratios, which we did a long time ago. We're going to say that the 10.5, the time of the running, is equal to the time of the biking, and we're just going to solve for x. So we're setting these two equations up here equal to each other, and we're going to solve for x. Now, this is a challenging problem once you've set it up if you don't remember what we did yesterday. Sorry, and obviously when I say yesterday, I mean, Thursday or Wednesday. We can't solve for these x's if I don't know the lowest common denominator. So I have an x and I have an x plus 14. So I won't spend too much time reviewing this, but just remember that the LCD, or lowest common multiple, is everything that the denominators have. So if it's numbers, I need to find the lowest common multiple of numbers. If it's variables, I need to make sure every variable is represented. So one of the fractions has x, and the other fraction has x plus 14. So my LCD will be both of those terms together. If you missed the last two classes, you might want to review or check out the video. But what I need to do is multiply both sides by the LCD, which you can see here, to clear the fractions. The whole point is to get rid of the x in the denominator. That's very difficult to solve for. Anyways, so here I'm going to multiply both sides and then cancel. This is very important step here. I'm going to cancel anything that appears on the top and anything that appears on the bottom. So the x and the x go away. The x minus 14 and that x minus 14 go away. And what I'm left with is a pretty straightforward algebraic expression. This thing that I just put a square around, everybody, should be pretty easy for you all to solve now, hopefully. What I mean is we're going to distribute that term out. So use the distributive property. We're going to multiply these guys out and then solve for x, which again, I shouldn't have to go through the solving for x at this point in the course, but just remember, if you need help or you need some, if you need my office time or something, just send me an email. I can make myself available, but you need to make sure you know how to solve for x here. So I put all the x's on one side, the numbers on the other, and then I figure out that x is 7. The speed, this person's running speed is 7 kilometers per hour, and the speed biking is going to be then 7 plus 14. Now, where did this come from? Well, I know that the biking speed was 14 kilometers per hour faster than the speed running. So I just take our 7. The person's running 7. I add 14, 21. Pretty good. I don't know if that's fast or slow. I don't know how fast. I think like the average running speed might be a little between 4 and 10. I don't know. Anyways, looks pretty good. Okay, what about number 2? This says Joan can paint a room in 3 hours. Bonnie can paint. These are very classic names where I'm from. So I have an aunt, Joan, and my first boss, her name was Bonnie. So these are 2 women I'm familiar with. It says Joan can paint a room in 3 hours. Bonnie can paint the same room in 5 hours. So how long would it take them if they worked together? Ooh, this is an interesting one. Okay, so we're trying to find time, right? How long would it take them? In the question above, we were trying to find speed. So we let the speed be equal x and the speed biking equal x plus 1, 4 or 14. Well, in this case, we're looking for time. Okay, so time is what we're looking for. We're going to call that x. X is the time required for both people working together. That's the key. They're working together to complete the task. So you can read the text here. It says one method to this approach, I'm just kind of reading this here, is to determine the portion of the job that each person can complete in an hour. You're just setting up like an arbitrary time. It could be 10 hours, it could be 3 days, but typically you keep it simple. So a number like 1 hour, because it says Joan can do the job in 3 hours. So if Joan can complete, just think about this logically. This is kind of where some logic skills come into this question. If Joan can, just say you can do an exam in 3 hours. Okay, think about this. You can write an exam, a final exam in 3 hours. So how much of that exam will you have done in 1 hour? Well, if it takes you 3 hours to do an exam, well, in 1 hour, you will only have 1/3 of that exam completed. So that means that Bonnie here, Joan, not Bonnie, Joan, her work rate would be 1/3 of the job per hour. Now, what does it say about Bonnie? For Bonnie, it says that she can do the room in 1/5 hours. So in 1 hour, I'm here talking about Bonnie, she can do 1/5 of the job in an hour. That's her rate. The key to these questions is to think of a rate, distance over time. This is the amount of the job that the person can do in an hour. You'll hear a lot more about rates if you guys move into calculus, electrical engineers and stuff like that. You'll be talking about rate a lot, and anybody doing physics really. Okay, so the time that we're looking for is x. We're trying to find out how much time that it'll take for these 2 people to do the job. So Joan takes 1/3 of the job per hour, x hours. So what we're going to do is put them together. 1/3 times x is how much of the job the person will complete. Bonnie, 1/5 x is how much of the job that they will complete. We're trying to find out X. How much time will it take them together? Now, the next part of this question is to come up with an equation. That's kind of like the challenging part. So the sum of the portions of the job, like if we add up their jobs together, we're trying to see how long it will take them to complete one whole job. And once I set this up, it looks a lot easier. Bonnie can do 1/3 of the job, okay, in an hour. So that's her rate. So 1/3 times the time it will take her, plus, I said Bonnie, I meant Joan, plus 1/5 for the second woman. That would be Bonnie. That's her speed, 1/5 times the time it will take her to complete the job. And together, they will actually complete the whole job. This one's actually nice. Once you set it up, the challenge with word problems is actually setting up the equation. Once it's set up, the math becomes pretty simple. I can tell you right now, when you do a word problem in the future, it won't be a complicated equation. So this is a pretty simple one. The LCD is 15. Now, where did that 15 come from? Well, 3, 6, 9, 12, 15, 18. These are the multiples of 3. For 5, we have 5, 10, 15, 20. And you'll notice that they both share the number 15. So I multiply both sides of the equation by 15. And basically, I distribute this out. So you can see it's going step by step here. I'm going to do one with you, don't worry. But the 15 and the 3 reduce to give me a 5. The 15 and the 5 reduce to give me a 3. And then I get this equation. Oh, guys, one thing I'll mention before I move into the next part. Very important you don't forget this, what I'm circling. So see this right here? Don't forget, when you multiply by the LCD, every single number gets multiplied by that number, everything. So this 15 and this 1 must be multiplied together as well. That's something I used to always forget when I was a student. So 15 times 1, don't forget, 15 goes everywhere. Okay, so this is actually pretty easy to solve. Okay, I'm going to get I'm going to get 8x equals 15, solve for x. This is fine. You don't need to use mixed numbers in this course. This is okay. So the answer would be 15/8. Now, this is okay for me if you wanted to just say 15/8. But if you turn this into what we would call a mixed fraction, it makes a little bit more sense verbally. So what you could do actually is even turn this into a decimal. So let's just look at this number as a decimal. Where's my calculator? Oh, hold on. My calculator's on my table.
1.875.
Yeah. Okay, cool. Perfect. So 1.875. This might make a little bit more sense to you. I don't know if you're comfortable changing numbers to mixed fractions, but this is what your calculator would give you. You can easily turn that into a decimal, and this would be probably an easier way to represent it. It would take 1 hour, 1.875 hours, you could say. So 1.875 hours. That's a little bit easier than, like, what I'm saying is, if you said to somebody, or if somebody said, how long will it take you to drive to my house? And you said 15/8 hours, the person might be like, what are you talking about? What is 15/8 hours? But if you turn it into a decimal, you could say like, oh, 1.8 hours, 1.9 hours. Still a weird thing to say to somebody, but it's a little easier to answer that. But guys, what I'm saying here is the fraction is fine. So if you just said 15/8 hours, that's good by me. You don't need to worry about mixed numbers. Okay, so these are pretty challenging, and the challenge here is that every question is going to be unique, meaning you have to set up the equations yourselves. So there's a couple, maybe we can do a few problems today. I don't want to do all the speed ones. I'll probably do, or we'll do together something like number 1 and something like number 4. These are really the two types. We can be talking about rates or speeds, and we can be talking about like time it takes. So um, I know it's pretty early on a Sunday morning. I can't believe it's almost June. That's scary. But I want to see if you guys can do number 1, and I'll do some with you together, of course. One thing I'll mention, if you are doing number 1, you can use this problem as a good reference. This problem here is going to be a good reference for that. Okay, so I'm going to put myself on mute. I'll give you guys a couple minutes to try number 1, and then I'll check your answers. We are also going to look at number 4. Okay, so I'll be back in, I don't know, 4 or 5 minutes, and we'll see if you guys can figure out number 1. Good luck, everybody. Okay, I got one answer in there. That looks good. Excellent. Oh, that was submitted a while ago. So Dustin is going really fast. That's excellent. Just take one more minute and we'll look at this answer together. And then I'm going to do number 4. Okay, let's look at this one. So a taxi travels 80 kilometers while driving in the rain. Um, okay, so that's the distance that this taxi is driving when it's raining. In sunny weather, the taxi drives 20 kilometers an hour faster and will travel 120 kilometers in the same amount of time. So what is the speed of the taxi when it drives in the rain, and what is the speed in sunny weather? So let's set up two situations here. We know that we're going to look at a taxi speed when it's sunny and when it's raining. Okay, so first things first, I know that the distance that these cars travel, these taxis travel, well, in the rain, it says it travels 80. That would be kilometers. And when it is rain, oops, sorry, I did that backwards. 80 goes here, right? 80 in the rain. And when it's sunny, it travels 120 kilometers. Okay, cool. Now, what's the rate that these, and again, when you hear rate, the rate is the speed that they're going. Well, that's what we're looking for, right? We're looking for the speed that they drive in the sunny weather and the speed that they drive in the rainy weather. And we don't know any of these numbers. So we're going to say that we know that this person can travel 20 kilometers faster in the sun. So let's set the speed in the rain as x, and let's set the speed in the sun as x plus 20. Now, the reason this becomes a rational expression is, well, the time, we don't know the time, but we know it's the same amount of time. Okay, so what we're going to do for the time is we're going to say if the times are the same, well, we'll say, well, the time is the distance divided by the rate. So time is the distance divided by our rate. So 80 over x. Okay, and they're doing this in the same amount of time. So what we can do is we can set up equivalent fractions. We know that the time is the same. So 120 over x plus 20 will be the same as 80 over x. And all we need to do now is solve for x. Now, in order to solve for x, we're going to need a lowest common denominator. And again, for the word problems, they're pretty easy. We know that it's going to be x and x plus 20. Okay, so, okay, first of all, where did that come from? Well, I have x plus 20 and I have an x. I'm going to need both of those things for my LCD. So I'm going to multiply both sides of this by x and x plus 20. Oops. Okay, let me change my color back to red here. Okay, I cancel anything that appears on both, or sorry, on the top and the bottom. So I'm going to cancel these x's. And what I'm left with is, I'm writing a bit too big here, sorry, is 120x equals 80x plus 80 times 20, which is 160. Okay, so now I'm going to get 120x minus 80x equals 160. So that would be 40x equals 160. So that finally means x is 160 over 40, or 40. So the speed in the rain is 40 kilometers per hour, which means in the sun, this person drives a little faster. So it would be 40 plus 20. It would be 60 kilometers per hour.
1,600, Mr.
The sun. Sorry?
18 multiply 20.
Oh, I forgot a zero, did I? Yes, of course I did. 1,600. It won't change.
Yeah.
It won't change my answer. Don't worry. Yeah, it's same answer. Don't worry. I just forgot put my zero there. 80. Thank you for that. 80 times 20 is 1,600, not 160. Careful with your zeros, but the answer is still the same. Cool. So the car goes 40 kilometers per hour in the rain. It's going 20 kilometers an hour, a little faster in the sun. So we're looking at 60 and 40. And let me check the chat. I think that's what Dustin got. Yeah, perfect. All right. Now let's look at another one. What about again, you guys definitely want to practice some of these. Numbers 2 and 3 are just like number 1. So let's look at number 4. Why don't you try number 4? Now, number 4 is a lot like example 2. So check out number 4. I won't say too much about this because it is exactly like example number 2. We're looking at the time it takes to do a job with two things together. One pipe can fill a swimming pool in 4 hours. Another can fill a pool in 12 hours. And we're going to use them together and see how long it will take them together to fill the pool. So I'll stop talking. If you need a reference, you can look at example number 2, and I'll check your answers in a minute. Just a heads up, when I set up my table, I'm going to call one pipe A and I'm going to call one pipe B. And again, we're thinking about the rate, we're thinking about the time, and then we're thinking about the portion of the job. And we're going to fill this out, this table, just like example number 2. Okay, I'll be back in 5 minutes. We'll check your answers. All right, just take another minute or so. You can put your answers in the chat if you want. Well, I already have one answer from Dustin. Perfect. So just take one more minute and we'll look at this one. And then maybe we'll do one more and then move into the next section. All right, let's check this one out here. So, where's my pen? Okay, so pipe A. Now, again, this is kind of like example number 2 when we said that, okay, the pipe can fill a pool in 4 hours. So what could it do in 1 hour? And guys, that's actually a fancy way of representing the rate. The rate is the amount it can fill over time. So we're going to say if it takes 4 hours to fill one pool, then the rate will be 1/4 of the job per hour. It can do 1/4 of the job per hour. So again, think about that. It takes 4 hours for it to do the job. Well, in 1 hour, it can do 1/4 of the job. We're just taking 1, dividing it by 4. And the same thing for B, pipe B. This can do 1/12 of the job per hour. So what about the time? Well, the time is what we're looking for. And we don't need to change anything with the time. Like we don't need to say x minus 2 or x plus 5. These guys, what I mean by guys, I mean these pipes are going to be working together. And we're trying to see the time that it takes them together. So the portion of the job, this pipe A can do 1/4 of the job times the time. Pipe B is going to do 1/12 of the job times the time it takes. This is what we would call their, well, I guess if this was like driving, it would be like their distance, but this is how much of the job they're going to be doing. So they're doing 1/4 of the work times the time it takes. Pipe B is doing 1/12 of the work times the time it takes. And again, like the question before it, we're going to assume, or I may actually not assume, but we're going to say that working together, so pipe A does 1/4 of the portion of the job. Oh, I shouldn't be writing it like that. Hold on. I should be writing it like this. So 1/4 x is x over 4. 1/12 x is x over 12. So x over 4 plus x over 12 will equal 1. That's what's happening here. So the pipe A is doing x over 4, pipe B x over 12, and together they're going to complete one job. And what I need to do is to get these guys together. So let's see. Oh, sorry, I didn't mean to do that. First things first, we need to do the LCD, the lowest common multiple. Now we're dealing with 4 and 12. So 4 times, oh, sorry, not 4 times, 4, 8, 12, right? You know, you can kind of see the idea here. I'm doing the multiples of 4, 16, 20, dot, dot, dot. The multiples of 12, 12, 24, 36, dot, dot, dot. The LCD or the LCM here will be the lowest common multiple of these numbers is 12. So I'm going to multiply everything in here by 12. Okay, so let me write this out again. Okay, let me write this out. Oh, I didn't save myself room here. Hold on. I meant to do that. So let's multiply this guy by 12. this guy by 12, and this guy by 12. Sorry, talking to myself. All right, so everything's multiplied by 12. Now let's simplify it. Well, this 12 and this 12 cancels. This 12 and this 4 are reduced, so we would get 3x plus x equals 12. 4x equals 12, which means x is going to equal 3. 12 divided by 3. I think that's what was people got in the chat there. Yep. Good job, everybody. Dustin and Suher, good job. 3. Oh, and word problem, we should say it takes both pipes 3 hours. Okay, I'm going to do one more, and then we're going to look at the next section. And I'm going to do a different one. I'm going to do one that isn't in the examples, maybe, and show you how some of these are still pretty easy, even though they can be asking different things. So let's go deep. Let's go down to the bottom 2. There's only 2 left. Let's look at number 9. I'll do this one for you. So this will be the last example, and then we'll go into quadratics. Scary. All right. So one number is 4 times another. The sum of their reciprocals is 5 over 12. So this is probably arguably the easiest one so far, but you need to know some language in mathematics. Specifically, you need to know what sum means and what reciprocal means. So sum means addition, and reciprocal means, for example, like it means when you flip a fraction, basically. So the reciprocal is the flipped version of a fraction. Okay, so this one's, we don't need a table to set this one up. There's no rates or times. The challenge in this one is with the language. So one number is 4 times another. Okay, so let's set one number as x, and let's set the other number. Okay, so we have 2. I'm trying to think of how I'd write this. 2 numbers. What would I say? This number 1, number 2. I don't know. We have 2 numbers. The numbers are going to be x and 4x. All right, one number is 4 times another. So one of the numbers will be x. The other number will be 4 times it. Problem here is we need to solve this. We need to figure out what x is. But it tells me that the sum of their reciprocals, so the sum of their flipped fractions, is 5 over 12. So let me just make a little note here. The reciprocal of x is 1 over x. Oops, I didn't mean to put that dot there. And the reciprocal of 4x is 1 over 4x. So this becomes pretty easy. 1 over x equals, sorry, not equals, plus, because we're dealing with the sum, 1 over 4x equals 5 over 12. Okay, now we're ready to solve. We just need to figure out my LCD, multiply everything by that, and then we're done. Now, LCD, well, this one's pretty easy. Well, it's kind of easy. First things first, I have the numbers 4 and 12. We already did this, the lowest common denominator or lowest common multiple. I think we just did this in the question up here. Oops, sorry. Right, the lowest common multiple for 4 and 12 is 12. So luckily, we already had that one done. All right, but that's not just the LCD. We also have an X. We also have a 4, well, just an X. Yeah, that's all we need. We have an X and we have an X. We don't need X squared or anything like that. The number 4 and the number 12, we know we're going to use 12, and we already have our X's. So the LCD is 12X. So I'm going to multiply everything here by 12x. All right, how do I want to do this? What I'll do is I'll write it again. I think I'm writing a bit too big as usual. I'll save some space. Okay, so let's multiply this by the LCD. So 12x, 12x. Oops, I can write that bigger. I have more room. And 12x. And you can cancel anything that appears on the top and the bottom. So I can get rid of the 12. I can get rid of the x and reduce the 12. I'm not getting rid of it. I'm reducing it. And here I can just get rid of the x. So what I'm left with is 12 plus 3 equals, oh, sorry, 12x, sorry, I just want to make sure I'm doing this right, equals 5 times x. Okay, that's pretty easy so far. So 12 plus 3 equals 5x. I'm just making sure I didn't make any mistakes. It looks good to me. So this ends up being 15 equals 5x. So obviously x is 3. Cool. Now it says, what are the two numbers? So, sorry, let me put a square around that again. The two numbers are 3 and 12. Now, where did I get that 12? If you don't know where I got that 12, 12 is 4 times 3. Remember, 4x up here. Okay, so I'll just put a star here. Remember, we have x and 4x. So my numbers are 3 and 12. X and 4 times x. Okay, cool. So I'll leave some of these for you guys to practice. Let's move into this. And this will be our last topic for today, solving quadratic equations. So this is really important for any of you guys who are doing physics now, or maybe in the fall you'll be doing physics. Definitely a really important topic. A lot of physics problems are based on solving something that looks like, for example, this, throwing a football or kicking a football. These are really, really useful for real life type of physics and engineering problems. So we're going to look at a few methods. I'll go a little slow through this. This is definitely a very important topic. And we're going to look at 3 different methods for solving quadratics. Personally, the first and last are my favorite. I like solving by factoring or solving by using the quadratic formula. Anybody doing physics will probably look at the quadratic formula a little bit in a little bit more detail. Okay, method number 1. Oh, well, first, what is a quadratic, right? It's not really saying anything about it. It's just giving you a lot of information here. What is a quadratic? I kind of mentioned this the other day when I was showing you a website. I can bring that up again. Just give me a second here. I'll bring it up. So a quadratic is, let me open up my graphing calculator, is something, it's a trinomial in the form of like ax squared. So we could say like 2x squared. I mean, that is a quadratic right there. I think, yeah, I'll make it negative so it looks a little different. So this is an example of a quadratic. You could say plus 3x. Let's make it a little bigger. Let's say 10. Oh, no, too big. Let's say 5x. And then you could say minus 1. This would be a quadratic. Okay, it doesn't need to be negative. The classic quadratic would look like this. Okay, and the solutions to your quadratic, and this is really important, guys. Well, it's important if you want to understand what a quadratic is. the solution of the quadratic is the x-axis. It's where it crosses the x-axis. So the solution, when you solve a quadratic, it's here and here. Now, for luckily, I'm going to say luckily for you guys, we're not going to get into graphing. If we got into graphing, this would be a little bit more complicated. But yeah, you can solve them as well by graphing. So if you let me go back to my notes here, you can solve these by graphing. So it says that there's three, we're going to look at three methods: factoring, completing the square, and the quadratic formula. You could also graph them, but they are much harder. If you guys didn't like graphing linear equations, you probably won't like graphing quadratic equations. So let's have a look at these methods. In Unit 1, we talked about linear equations. And we solved linear equations in one variable in this form. Well, when we take a second degree polynomial, this specifically is a trinomial, I guess it doesn't need to be, but when we take a second order or a second degree polynomial, so something to the power of 2, it is not linear anymore. So a linear equation has, I really want you to look at the difference here. Look at what I'm circling, or crossing out. A linear equation has 1x. A quadratic equation has an x squared. And the linear equation looks like a straight line. A quadratic equation looks like a U. Okay? Or I guess I could draw it like this. Well, I'll leave the lines away. So a linear equation is a straight line. A quadratic is written in the form you can see here below. It's written as like a U. So yeah, that's what a quadratic is. Now, typically, very importantly, the following equations are quadratic because we can rearrange them, and this is going to become important, to write them like this. Just imagine I had this equation. Negative 4x squared plus 4x equals 1. Well, I could move the 1 over, and it would turn into an equation in the form of a quadratic equation. I could do the same with all of these, move this over and factor this out. We're going to practice this. But what I'm saying is all of these equations here on the top are quadratics because they have an x squared. Mostly, that's the most important part. And they all take the form ax squared plus bx plus c. Ax squared plus bx plus c. And they don't need to be
Equal 0.
equals 0, exactly. Thank you. And they don't need to be positive. Don't worry about this plus sign. It just has to be something squared plus something with an x, or x squared with an x with a constant number equals 0. The equals 0 is actually, I'm glad that you mentioned that. It's actually a really important part for solving this. So we did this all the way back in Unit 1, probably topic 1. The rule now is, or the way that we can solve a quadratic is, if you have two numbers equal to 0, and you'll see what I mean by this in a minute because we're going to actually factor this. If two numbers equal 0, then A will equal 0 or B will equal 0. We don't know which. They both could equal 0, not likely. But if A times B equals 0, let me write something else here. If A times B equals 0, then A or B must equal 0. Or both of them. Or sorry, and it could be like one of them or both of them. But A or B must equal 0. One of these numbers here has to equal a 0. So we're going to apply this to factoring. And there's examples here. This is a lot easier than it looks. You guys have actually already done this. So I'm going to show you how to apply it to a quadratic. Okay, so let's look at this example. And then I'm going to show you an example or two. Oh, there's 3, 4, there's so many. And then we'll get you guys to practice. I don't know why there's so many of them, but anyways. Okay, sorry. So for example, the quadratic equation, x squared minus x minus 12 equals 0. We could write that in factored form, and you guys already know you should remember how to factor. I will review factoring in a minute. But using my zero product rule, if I can write it like this, well, then either x minus 4 will equal 0 or x minus 3 will equal 0. So what we can do to solve this quadratic equation, and I used to tell this to my students back, years ago, is you split the equation in half. Okay, so factor it and then split it in half and solve for x. So our possibilities for this could be x equals 4 or x equals minus 3. These are possible solutions to this. So I'm going to show you how this works. Don't worry. The steps that you do are write the equation in the form ax squared plus bx plus c. So write it like this. Then factor. Again, I cannot stress this enough. If there's anything you guys think like in the next week or two, make sure you factor and you practice factoring. Once you factor, you set each factor equal to 0 and solve each equation. We can always check our answers by putting it into the original equation. Okay, that might look confusing, but let's look at some examples. It's actually not as bad as you think. It really isn't that bad. Okay, so question or example number 1. Here is my problem. This will say, if this was on a test or something, this would say solve. Okay, so not the solution, but like the question would say solve. There we go. Sorry, up there, solve. Well, we've never really looked at how to solve, x squared or anything like that. So what are we going to do? Well, first step, write the equation in the form of ax squared plus bx plus c. So what I mean is take this equation, move the 12 over. Basically, you're going to set everything equal to 0. So take all of your numbers and move them on the left and make sure it's equal to 0. Step number 2, factor that equation. Now, you guys will definitely probably need to review factoring. Where did this factor come from? I'm not going to review factoring too much because we don't have like all the time in the world. But I can show you this one. I just need somewhere to write it where I have room. Okay, I'll write it like right up here in the corner, guys. How did we get from this number to this number? Okay, well, let's see. 2x squared minus 5x minus 12. I'm going to factor this. Now, I'm not going to set equal to 0. I'm just factoring. The way it works is you multiply the first and last together. Okay, so we would have negative 24. And then you take the middle number, negative 5. And what I'm trying to do is trying to find two numbers that will multiply to give me a negative 24 and add to give me a 5. Okay, so two numbers that will multiply to give me a negative 4 and add to give me a 5. Okay, so my numbers, when I do that, again, I'll say that again, they need to multiply to give me a negative 24 and add to give me a negative 5, or negative 8 and positive 3. Okay, so negative 8 and 3 are my numbers. Negative 8 times 3 equals 24. Well, this is more specifically negative 24. And negative 8 plus 3 equals negative 5. So then what I do is I split my middle term. So I'm going to go 2x squared minus 8x plus 3x minus 12. Sorry, I don't have a lot of room here. Now, if anybody is extremely confused right now, we did this weeks ago. So, you know, I don't have time to completely teach factoring, but we did do this many, many weeks ago. Then what we do is we group the first two terms and the second two terms, and we factor those. So what I end up getting there is I'll take a 2x outside of x minus 4. Here, I'll take a 3 outside of x minus 4. And there's my answer. Well, there's where my answer comes from. Sorry there, ran out of room on my phone. So x minus 4 is one factor. 2x plus 3 is my other factor. Again, if anybody is sitting there very confused, you need to go back and look at factoring. And I think it was topic 11 or 12. We have done this. So, okay. I have these guys factored. All right. I'm going to set each one equal to 0. So what I do is I basically draw a line down the middle. And I'm going to set one of them equal to 0 and the other equal to 0. And then I'm going to solve. Okay, x equals negative 3 over 2 or x equals 4. You can check your answers by putting them back into the original equation. So if you want to check your answers, you can put them back in the beginning. But that's it. Okay, let's look at another one. This one's a little bit more complicated here because we have the fraction already in this form. It's already good to go. Now you guys might be noticing, wait a minute, there's no c here, but that's okay. The c would just be a number and what we would call a constant. That's why it's called c. So in this case, c is equal to 0. So c is there, it just happens to be equal to a 0. Now the problem with this one is we have fractions and we do not ever want fractions. So we clear the fractions by using the lowest common multiple. So that means multiply it by 6. Where did I get 6? I have 2 and I have 3. The LCM is 6. So I multiply everything by 6. Now, one thing you'll notice, guys, is when you multiply a number by 6, it still equals 0. So there's 0 right here. Okay, so 6 times 1/2 is 3. 6 times 2/3 is 4. You can check that on your calculator if you don't believe me. And now I have my two factors. So it's been factored. Split it between your factors. I have x, so x equals 0. That's one term. And I have 3x equals 4. When you factor it, split it between the two factors. Even though this is only an x, it's still a factor. So split it down the middle, and you'll get your two terms. You'll notice for this solution, I didn't have to do the workings I did up here. I didn't have to actually find the product and the sum and multiply them or add them because this was actually quite an easy one to factor. Right? We didn't need anything special to factor this. We just removed an x from both sides. Again, I was talking to another instructor or another teacher over the weekend, and he just started this on Thursday, and he said that the students were really struggling with factoring. So make sure you practice factoring. All right, hold on. I got a message in the chat there. Oh, sorry. All right, so solve. Now look at this one. This one looks crazy, right? I want you to solve 2x times x plus 5 plus 3 equals 2x squared minus 5x plus 1. And you need to solve this using the zero product rule. The big challenge here, guys, is this looks crazy, but it's actually not. What we're going to do is simplify this and then put all of the numbers on one side. So this is actually not that challenging of a question. Like, well, it looks crazy, but when you get the answer, this one's actually quite simple. I don't really know why this one is put in there, but anyways, let's look at the solution. Okay, so 2x, we're going to clear the parentheses, which means clear the brackets. That's our first step. We cannot simplify this until we get rid of these brackets. So I multiply these guys out. So I get 2x squared plus 10x plus 3 equals 2x squared minus 5x plus 1. Okay, so what I'm going to do is I'm going to put everything on one side and set it equal to 0. So I move everything over, and when you do that, right, it tells you what to do here. It says make one side of the equation equal to 0. What happens when we do this is, and it does skip a lot of work, but when we do this, the 2x's cancel, and we're left with 15x plus 2. This equation, turns out, is not a quadratic. This is a linear equation. So you can just solve this one normally. 15x equals minus 2, solve for x. Again, I don't understand the book sometimes, but there it is. So when we simplified this, we figured out, or we noticed that this is not a quadratic. This is a linear equation. So we can solve this one like normal. All right, I'm going to read one more, then I'll show you some, and then we'll check the time. Okay, so what about this one? So this one is a quadratic. Oh, this is awesome, actually. Again, key thing here is put it into the form ax squared plus bx plus c equals 0. We can't do that with this equation until we simplify it. So first things first, clear your parentheses. So multiply this term out. And then next, combine all of your like terms, meaning move things to the left, combine anything that has an x or anything that has an x squared. And what you'll notice is when you combine your like terms, you get this. Okay, factor. Now, again, I've said it 50 times today, make sure you review factoring. This is a difference of squares. Okay, so this difference of squares here, we've already done before. This is going to be and I'll erase the word difference of squares because what I'm going to explain to you or show you is what you do when you see a difference of squares. So if you have like a squared minus b squared, what it ends up being is a plus b times a minus b. We've done this 100 times in class. So 36x squared is just 6x. It's going to be minus 5, 6x plus 5. Okay, that's a difference of squares. And again, this was on test number 1, so that's just review. So again, what you do is you split the fraction down the middle. 6x minus 5 equals 0. 6x plus 5 equals 0. And you solve. So I won't go over the solving, right? You guys should know how to solve these equations, but there you go. These are your answers. So let's look at some together, right? Like, again, you guys know I don't really like, it's not easy going through these examples. Let's look at some of these together. All right. So how about this? Let me try question B, and then I'll get you guys to try A and C. Now, these have already been factored. Okay, these have already been factored. There's a little thing special about question D, but that doesn't, we're not going to worry about D for now. So I'll do B and you guys try A and C. It is easier than it looks. So this is factored. Check mark. It's good. It's already factored. So what I'm going to do is I'm going to split it down the middle, and I'm going to say 2y plus 9 equals 0. And I'm going to say 5 minus 1 equals 0. Now all I do is I solve for y. So this would be 2y equals negative 9, y equals negative 9 over 2. And here I get 5y equals 1, y equals 1 over 5. That's it. I'm done. Now, key word here is or. My solution is negative 9 over 2 or 1 over 5. That's it. That's all you need to do. Let me check the chat here. Okay, so Bilal is already doing number A. So guys, why don't you take a minute or two and try number A. Try A and try C. Try A and C. I'll show you D in a minute, but try A and C. Put your numbers in the chat, or answers in the chat. Okay, let's look at the answers. I'm going quick through this one because this is actually pretty straightforward. Oh, that's a good question. I have a private message from Fatima about, do you have to check your answers or will you lose marks? Let me just check something. Hold on, just 1 second. I'm just seeing something. No, it doesn't look like you'll lose a mark. You won't lose a mark if you don't check this answer. No. So again, the private message I got was, do we have to check our answer and write it out or will we lose a mark? No. Checking it just confirms that you have the 2 correct answers. If this was a word problem, but I don't see any word problems coming up, you're okay. What I mean is you won't lose marks if you don't check it. I do recommend checking it though, if like it was on your test or an assignment, just to make sure your answers are okay. All right, so let's look at these answers. Sorry, excuse me. So x plus 3, x minus 5. Well, that's going to be x plus 3 equals 0, x minus 5 equals 0, x will be negative 3, x will be 5. Okay, so that's it for A. Easy. What about C? Well, x plus 4 equals 0, 10x minus 3 equals 0. So x will be negative 4, x will be 3/10. Again, I'm going a little quick through the mathematics here. Make sure you're comfortable with rearranging equations. Very, very important. Okay. Just to answer that question in the chat, so I just looked ahead. So again, it was Fatima. I know you wrote me a private message, but it is a good question. Fatima again asked, do you need to check your answer or will you lose a mark? I just looked ahead. In topic 19, we're going to apply quadratic equations. In topic 19, you might have to check your answer. But if it's a question, and again, what I mean is in topic 19, we're going to be doing like word problems. But in a question like this, you do not need to check your answer for a question like this. Okay, so when we get to topic 19, you'll see that we'll get there probably tomorrow or the next day. What was I going to say? Oh, yeah, you might have to check your answers. Okay. So let's just do a couple more. I know we're getting late. It's been a long class, but I'd like to do some of these. And then that'll be it for today. So before I do that, I just want to explain something about question D. Question D, this number 4 here might confuse a lot of you, and it really doesn't need to be there. Now, why? Well, I can get rid of this number 4 very easily. I can divide both sides by -4 and it just goes away, right? 0 divided by -4, it's gone. So what I'm really factoring here is x minus 7.5 and x minus 9.3 equals 0. So x equals 7.5, x equals 9.3, done. Easy. Okay, so let's look at some harder ones. So guys, I'll maybe do 1 or 2 of these. Well, here's what I'll do. I will do a couple of these and then I'll let you guys go because this has been a long class. But I'm going to ask you guys to practice this over the next, over tonight. You know, you don't have any assignments or tests or anything due. So just try this. Sorry, I'm just looking at an email I got. Just try a couple of these tomorrow night and we can look at your answers. Or sorry, try a couple of these tonight and then we can look at your answers. So let me show you some. Let me do some. Okay. So this one here, what am I going to do? Well, first thing I'm going to see if I can factor, right? And I can't really factor. There's no number I can remove or take out of anything. So this is it. This is done. X squared minus 2x. What I'm going to do, because I can't factor this, I'm going to subtract a 35 and set it equal to 0. I'm going to put it in the form ax squared plus bx plus c equals 0. Okay, I'm going to put it into that form. And the reason I'm doing that is because there's nothing else I can do. I can't factor it. Not like this, I can't anyways. I need to put it into the form of a quadratic. All right, now what do I do? Well, I need to think of 2 numbers that are going to multiply to give me a 35 and add to give me a minus 2. 2 numbers that are going to multiply to give me a 35, a negative 35, and add to give me a minus 2. Well, let's think of the multiples of 35. 7 times 5 is certainly a multiple of 35, or are multiples of 35. Now, one of them needs to be negative for this to work. And the answer is negative. I'm sure this is in the chat here. Yep. Thank you, Abdullah. Negative 7 times 5. Okay. So what this means is you can split the middle term if you want to, but in this form where there's no number in front of this just becomes x minus 7 and x plus 5. Again, you need to review, make sure you review factoring if you don't know where this came from. Okay, so I'm going to change the color of my pen. I'm going to set it to red. x minus 7 equals 0, x plus 5 equals 0. X equals 7, x equals negative 5. Done. It's as easy, well, I shouldn't say it's as easy as that, but it's not too bad. Okay. I'll leave, I'm trying to think of good, like F is a good one for you guys to do. I'll leave F and you guys can try F. Let's say you can try F and maybe H or something tonight. For F, just keep in mind, it's not really going to be a quadratic in the form of ax squared plus bx plus, I mean, it will, but what you're going to do is you're going to move the 7 over and realize that you can just factor this normally. So I'll stop talking. I'll leave F for you guys to try tonight. So I'll get you guys to try F and H tonight. Okay, let me do one more. And then halas, that'll be it for today. I'm going to pick a hard one for myself. Let me do number I. Okay. And then again, guys, tomorrow we'll come back and we'll look at a couple of these things. All right. So don't worry, if you don't get this tomorrow, I'm going to do a bunch more of these. Okay. But let me do I, and then that'll be it for today. Okay. There's a problem with I. It looks so easy, but it's not, there's work to be done for question I. This is factored, but there's a problem. It's not equal to 0, and that gives me a huge problem. So what I need to do, and it's kind of like, fixing a car, I need to take this completely apart and then put it all the way back together again. What I mean is I need to get it in the form ax squared plus bx plus c equals 0. Yes, this has been factored, but it's not equal to 0. So I need to work with this. Step number 1, I'm going to multiply. I'm going to expand this. So let me go piece by piece. 2x times x, that would be 2x squared. 2x times a negative 1, that's negative 2x. Now I'm going to take this term, negative 1 times x, that's minus x. Negative 1 times negative 1, positive 1. This is equal to 6. Now what I'm going to do is I'm going to put everything together. So 2x squared, this will be minus 3x, and then this will be minus 5. Where did the minus 5 come from? I just moved the 6 over. Okay, next step. I need to find a numbers that are going to I'm going to try to factor this is what I'm trying to say. So my next step is factor. All right, my product, the numbers that I'm looking at multiply together are 2 and negative 5. So negative 10. The number in the middle is negative 3. And what I'm trying to do is I'm trying to find two numbers that multiply to give you a negative 10 and add to give you a negative 3. So again, I'm trying to multiply to equal negative 10 and add to equal negative 3. That's the question. So I'm going to pick blue. I'm going to switch my color up. All right. What are the multiples of 10? There's 1 and 10, 2 and 5. So I'm guessing 2 and negative 5 would be good answers here. Right? 2 and negative 5, that makes sense. Okay, so what I'm going to do, I'm going to split this middle term into 2x and negative 5x. All right, so what I have left is 2x squared plus 2x, because it's positive, minus 5x minus 5 equals 0. Again, guys, you need to review. If you don't know what I'm doing now, please review factoring. Okay, put brackets around the first two, put brackets around the second two. So what I'm going to do here is I'm going to remove a 2. This leaves me with x, sorry, not a 2. I'm going to remove a 2x, which leaves me with x plus 2. And over here, I'm going to remove a negative 5. Oh, sorry, not x plus 2, x plus 1. Right? I'm factoring out a 2x, so that's where the 1 comes from. So here I'm going to take away a negative 5, and I will get x plus 1. Remember, negative 5. I'm taking away a negative 5, so that will leave it as positive. All right, we're almost done. I picked this one because it's a hard one. So the factored form, 2x minus 5, x plus 1 equals 0. And now I solve. So put a line down the middle, 2x minus 5 equals 0, x plus 1 equals 0, and solve for x. So I'm out of room. So I'm just going to write this again. I'm going to get 2x minus 5 equals 0, x plus 1 equals 0. So x is equal to 5 over 2, and x is equal to negative 1. It looks like a lot of work. Let me zoom out here. It's actually not. I just wrote really, really, really big. And I wrote a lot of workings, which you guys, don't necessarily need to write down. So guys, that's it. I went again, trying to go a little further here with this today, but we're out of time. I will show you more of these tomorrow. But what I recommend is maybe tonight for practice to try the ones that I didn't do. So like F, G, and J. You could try F, G, and J. Give them a try. If you don't know what to do, that's okay. We'll do a couple more tomorrow. But that's it for me. All right, guys, so I'm going to hit stop record. Any questions, let me know.